Hi friends, we are discussing here NEET 2025 chemistry and my version of question paper is 47 Narmada and the question number is 46. The first question. The question is like this: if the molar conductivity lambda molar of a 0.05 mole per liter solution of monobasic weak acid is 90 Siemens centimeter square per mole, its extent of degree of dissociation will be, assume lambda 0 plus is equal to 349.6 and lambda 0 minus 50.4, both in Siemens centimeter square per mole. See, in electrochemistry we have learned that degree of ionization of a weak monobasic acid of the type HA or BOH, weak monobasic monoacidic base, BOH. In both these cases, we have alpha degree of ionization is equal to conductance at the given concentration by conductance at infinite dilution. Conductance at the given concentration by conductance at infinite dilution. That will give you the degree of ionization. Here, this value, lambda m or lambda c is directly given to be 90. Okay, in the regular unit we study them, 90. And instead of giving lambda 0 directly, they have given the conductance at infinite dilution of both the cation and anion of that electrolyte. Simply add them up to get the lambda 0 of the electrolyte. These values are 349.6 and 50.4. You add them, divide 90 with that value. You get a 0.225. D is the answer for the first question here. Okay. The next question, question number 47. It's a statement-based problem. Statement 1. A hypothetical diatomic molecule with the bond order 0 is quite stable. Even without reading the next one, we can verify this statement. A hypothetical diatomic molecule with the bond order 0 is quite stable. We know that whenever the bond order is positive value, the species, it can be molecule, neutral molecule, cation or anion, it will be stable only when the bond order value is greater than 0 or is positive. Whenever that bond order value is 0 or negative, the species will be unstable. This is the rule we study. Then the very first statement is wrong. A hypothetical diatomic molecule with a bond order 0 is quite stable is wrong. Now the statement 2. As bond order increases, the bond length increases. We know when the bond order increases, the bond becomes shorter. And so the molecule becomes stable, isn't it? So here the statement is as bond order increases, the bond length increases. Wrong. When bond order increases, bond becomes shorter and stable the molecule. So statement 2 is also incorrect. So both statement 1 and statement true or false. 3 is the answer. Question number 47. 3 is the answer. Okay. The third question, 48. Question number 48. The ratio of wavelengths of light absorbed by hydrogen atom when it undergoes n is equal to 2 to n is equal to 3 and n is equal to 4 to n is equal to 6 transitions respectively. See, an energy versus electron transition. Energy either absorbed or released during an electron transition is given by the equation E x to y is equal to 2.18 into 10 to the power of minus 18, the constant, into z square into 1 by x square minus y 1 by y square. Okay, you know that. Now we also know that energy is equal to hc by lambda. Agreed. So hc by lambda is equal to this value. Okay, avoiding constants, we can say 1 by lambda proportional to 1 by x square minus y square. Okay, so we want the ratio of the two transition, lambda 2 to 3 and lambda 4 to 6. That is the thing here asked. So, in a way to get a positive value, 3 square minus 2 square divided by 6 square minus 4 square. Okay, simple. 9 minus 4 by 36 minus 16. 5 by 20 is equal to 1 by 4. So, this is the answer here. The ratio of wavelengths of the radiations emitted will be in the ratio 1:4. Okay, so our answer here is the option 1 is the answer for the third question in this question paper. Okay. So next question for 9, it is from coordination chemistry, and see here they have given 4 different complex ions, and you have to arrange them in the increasing order of their wavelengths that would they absorb. Okay, we know that complex molecules and ions can absorb radiation for electron transition, particularly d-d transition of electron. For d-d transition of electrons, they can absorb radiation, and greater the energy requirement for this electron transition, greater the frequency of the radiation they absorb. Higher the energy requirement for d-d transition, higher will be the frequency absorbed and lower will be the wavelength absorbed. Hope you understood. So here in this particular question they ask us to arrange these ions in the increasing order of the wavelength they absorb. Okay, so we have to first place that complex ion which absorbs the highest frequency radiation and so lowest wavelength, because we want an increasing order of wavelength. Now the question comes, what are the factors that controls the frequency, wavelength, energy, etc. of the radiation that are absorbed by these complex ions? We have to remember that electrons are absorbed for d-d transition from T2G Eg for T2G Eg transition of electron. Okay, and important factors that affect this absorption are: 1, octahedral complexes have greater d-d splitting, and so naturally octahedral complexes absorb higher frequency radiation when compared with the tetrahedral complexes which have low d-d splitting. Okay, now listen, the first complex is CuNS3 6 times 3 plus, second is CuCN6 3 minus, third CuH2O 4 times 2 plus, D TiH2O 6 times 3 plus. See, here 3 are octahedral complexes because they all are having the coordination number 6, and one is tetrahedral complex CuH2O 4 times. So as a general rule we can say that being octahedral complexes, the 3 complexes would absorb higher energy or lower wavelength compared to the tetrahedral complex. Now among these 3 octahedral complexes, how to distinguish? See, here cobalt NS363 plus, the charge of the cobalt ion is plus 3. There are also cobalt CN6 3 minus, there are also cobalt is plus 3. In TiH2O6 3 plus, there are also the charge is 3 plus. As a rule, greater the charge on the central ion, higher will be the frequency absorbed. But here all the 3 are having the same charge on the central ion. Now the ligand. See, the strongest ligand here is cyanide ion. Greater the strength of the ligand, more will be the frequency absorbed. In that case, we can say that CuCN6 3 minus will be absorbing the radiation of the highest frequency, and so will be positioned first in the list. So our supposed answer will be starting with the B, less than. Second one, here ammonia is the ligand, there water is the ligand. We know ammonia is stronger a ligand than water molecules, so we expect A to be the next one, followed by, now these 2 complexes both are having water as ligand, but here the charge is 2 plus, there the charge is 3 plus, so we expect D to be the third case. Okay, because it is having 3 plus charges also and octahedral complex 2, so D. So finally we have the tetrahedral complex C. So B, A, D, C will be our answer, and that option is option 3. So for this question our answer is option 3. Okay. See, the next question is from kinetics, chemical kinetics. If the rate constant of a reaction is 0.03 per second, how much time does it take for 7.2 mole per liter concentration of the reactant to get reduced to 0.9 mole per liter? See, here they have given the rate constant of the reaction. While they give the rate constant of the reaction with the unit, it also tells you what is the order of the reaction. For instance, in this particular problem, they have given the rate constant to be 0.03 per second. Per second is the unit of rate constant for the first order reaction. So indirectly they have mentioned that the reaction is first order. Okay, K is given 0.03 per second. Then they have, in the question they have provided that initial concentration given 7.2 molar. Finally it becomes 0.9 molar. And you are asked to find the time taken for 7.2 molar to become 0.9 molar. You can directly use the integrated rate law for the first order. T is equal to 2.03 by K log C0 by Ct, isn't it? 2.03 by 0.03 log 7.2 by 0.9. 7.2 by 0.9 is 8. So log 8. Log 8 is 3 log 2. Log 8 log 2 to the power 3 means 3 log 2. So that 3 goes with this 0.01. So it becomes 23.03 into log 2. Log 2, you know, 2.03 into log 2. We several times repeated. 2.303 into log 2, 0.693. That we have learned in many problems. 2.03 into log 2, 0.693. So our result becomes 0.693 divided by 0.01 means 69.3 seconds. Calculation is an easy one. You don't have to depend upon a calculator which is not even with you. Okay, then you get the answer even without the much confusion, I say. Even without any confusion, you get the answer as 69.3. 2 is the answer here. Hope you understood that also. Next question is from organic chemistry. The first year chapters, some simple principles of organic chemistry from that chapter based on the separation of organic compounds. Okay, separation of organic compounds. Listen, it is a matrix type. Match the following type. On the left hand side, in the set 1, we have chloroform plus aniline, crude oil from petroleum, glycerol from spent lye, aniline plus water. On the other side, you have 4 options of different methods of separation or purification. We have to match them accordingly. Okay, the first one. See, this question is purely from our textbook because all these are there. All these are there given as examples. Nothing from outside. Chloroform plus aniline, if you remember, in simple distillation, we have given this as an example. They differ very much in their boiling point, around 100 degree or so. So they can be easily separated by simple distillation. So chloroform plus aniline, simple distillation, is a memory-based problem. Next one, crude oil. Petroleum industry, there are several fractions to be separated. They don't differ much in their boiling point, so fractional distillation is the method. Fractional distillation is the method that comes to our mind very easily. Then glycerol from spent lye. What is spent lye? See, when soap is manufactured by the hydrolysis of oil, oils are esters of long chain fatty acids and glycerol. So after hydrolysis, the long chain fatty acid side precipitates as sodium or potassium salt, that is soap. Sodium or potassium salt of long chain fatty acid is called soap that gets precipitated. So what remain in the aqueous solution? Glycerol. So if you want to extract glycerol, huge amount of water has to be evaporated out. Then only you will get glycerol. Glycerol has much high boiling point. So that will remain there. To boil off so much of water, so much of fuel will be required. That consumption of fuel can be minimized if you carry out this distillation under reduced pressure. Under reduced pressure, boiling point of water will be lowered. So water get easily converted to its vapor. So we can save fuel. So we can say glycerol from spent lye can be separated by distillation under reduced pressure. Reduced pressure, or sometimes it is said vacuum distillation. Okay, even though it is not pure vacuum. Okay, and finally we have aniline plus water. It's given as an example in our textbook while we discuss steam distillation. Turpentine oil with the water or aniline with the water, they are separated by steam distillation by passing steam into a mixture of the things to be separated. Only steam distillable thing comes out along with the steam. Aniline thus comes along with the steam to outside and collects separately. Since water and aniline are immiscible in the collection vessel, they will form two separate layers. You can separate them using a separating funnel. So, aniline water mixture which are immiscible, and at the same time aniline being steam volatile, aniline can be separated from water by steam distillation. And all these cross matchings gives you two as the answer. Among the options given, 2 is the answer for this question. Only this much questions in the first section. We will discuss the next questions in the next session. Okay, take care.